Imagine waking up tomorrow and discovering that somewhere beyond everything you can see, beyond every star and galaxy, there exists another universe where another version of you made different choices. In that universe, maybe you took a different job, met different people, or followed a completely different life. Perhaps there is a universe where Earth never formed, or one where dinosaurs never went extinct. It sounds like science fiction, but some of the greatest physicists in the world believe this idea might actually be real. The question is not just whether parallel universes could exist, but whether our universe might be only one tiny bubble in a much larger cosmic reality. For centuries, humans believed the universe was everything that existed. The stars, galaxies, and cosmic voids stretching billions of light years in every direction were thought to represent the full extent of reality. But modern physics has begun to whisper something far more unsettling. What if our universe is not unique? What if the cosmos is filled with countless other universes, each with its own laws of physics, its own timeline, and its own versions of events? The concept of parallel universes, often called the multiverse, may sound fantastical, yet it emerges naturally from several serious scientific theories. And if these theories are correct, the truth about reality may be far stranger than anything we have ever imagined. To understand how scientists arrive at such a radical idea, we first need to step back and look at the story of our own universe. Everything we know began around 13.8 billion years ago with an event known as the Big Bang. In a single moment, space itself began expanding from an incredibly hot and dense state. Matter formed, galaxies assembled, and over billions of years, the universe evolved into the vast cosmic web we observe today. At the first glance, the universe appears enormous, stretching tens of billions of light years across. But even this immense scale might represent only a tiny fragment of a far larger reality. One of the first hints that multiple universes might exist came from studying the structure of the cosmos itself. When astronomers examine the observable universe, they notice something peculiar. No matter where they look, the universe appears remarkably uniform. Temperatures across vast distances are nearly identical, and galaxies are distributed in patterns that suggest the early universe underwent an incredibly rapid expansion. This expansion, known as cosmic inflation, occurred in a fraction of a second after the Big Bang. During inflation, space expanded faster than the speed of light, stretching tiny quantum fluctuations into the large-scale structures we see today. Cosmic inflation explains many mysteries about the universe, but it also leads to surprising consequences. According to some versions of inflation theory, this rapid expansion never completely stopped. Instead, different regions of space may have continued inflating, constantly creating a new bubble universes. Our universe could be one such bubble, floating in a vast cosmic foam of another universes. Each bubble might contain different physical laws, different constants of nature, and entirely different cosmic histories. If this idea is correct, then the universe we inhabit is not the entire cosmos. It is just a small pocket within an unimaginably larger multiverse. Beyond the limits of our observable universe could lie other universes expanding in every direction, forever separated from us by enormous distance of inflating space. But inflation is only one pathway that leads scientists toward the multiverse. Another emerges from the strange and counterintuitive world of quantum mechanics. At the smallest scale of reality, inside atoms and particles, the universe behaves in a way that seems almost magical. Particles can exist in multiple states simultaneously, a phenomenon known as superposition. They can also become entangled, meaning the state of one particle instantly influences another, even across vast distances. One interpretation of quantum mechanics takes this strangeness to an extreme conclusion, known as the many worlds interpretation. It suggests that every quantum event causes the universe to split into multiple versions of reality. In one universe, a particle moves left, while in another, it moves right. In one universe, a coin lands head, and in another, it lands tails. Over time, these branches possibilities create an ever-growing tree of parallel universes, each representing a different outcome of every possible event. If this interpretation is correct, then an unimaginable number of universes exist, each containing different versions of history. Somewhere out there could be a universe where humanity never evolved, another where civilization spread across the galaxy, and another where Earth itself never formed. Yet, there is another surprising reason scientists consider the possibility of parallel universe. It comes from a puzzling question about the laws of physics themselves. When physicists measure the fundamental constants that govern our universe, things like the strength of gravity or the mass of elementary particles, they discover something astonishing. These values appear to be perfectly tuned to allow the existence of stars, planets, and life. If gravity were slightly stronger, stars might burn out too quickly for life to evolve. If it were weaker, galaxies might never form. Even tiny changes in the laws of physics could create a universe that is completely lifeless. This apparent fine-tuning has puzzled scientists for decades. Why does our universe have exactly the right conditions for complexity and life? One possible answer is that there are countless universes, each with different physical laws. Most of them would be chaotic, empty, or short-lived. But in a few rare universes like ours, the conditions would happen to allow life to emerge. We find ourselves in one of those rare universes simply because we could not exist elsewhere. This idea is sometimes called the anthropic principle. And while it does not prove the existence of another universe, it offers a possible explanation for the strange precision of our cosmic laws. The concept of parallel universe also appears in another ambitious theory known as string theory. In this framework, the fundamental building blocks of reality are not tiny particles, but incredibly small vibrating strings of energy. These strings vibrate in different ways, producing the particles and forces we observe. However, string theory requires additional dimensions of space beyond the familiar three. In some versions of the theory, there could be up to 10 or even 11 dimensions. These extra dimensions might be curled up so tightly that we cannot detect them directly. But they could also allow the existence of multiple universes separated by higher dimensional space. In some models, entire universes could exist on giant membranes known as branes, floating within a higher dimension space. Our universe could be one such brane, with other universes existing just millimeters away in dimension we cannot perceive. If this sounds bizarre, That's because it is. Yet, the mathematics of string theory continues to suggest that such possibilities cannot easily be ruled out. Despite these compelling ideas, the greatest challenge facing the multiverse concept is evidence. Science depends on observations and experimentations, and by definition, other universes would be incredibly difficult to detect. If they exist beyond the observable limits of our universe, we might never see them directly. However, some scientists believe subtle clues might still be hidden in the cosmic background radiation, the faint afterglow of the Big Bang. If our universe collided with another bubble universe in the distant past, it might have left strange patterns or temperature anomalies in this ancient radiation. Researchers have searched for such signatures, though so far no definitive evidence have been found. Another possibility involves gravitational waves, ripples in space-time caused by powerful cosmic events. Collisions between universes or interactions in higher dimension might produce unique gravitational signals that future detectors could observe. Even if we never find direct proof, the multiverse idea continues to fascinate scientists because it emerges naturally from several independent theories. Inflation, quantum mechanics, and string theory all hint at realities beyond our own. And if parallel universes truly exist, their implications would be profound. It would mean that reality is far larger and more complex than anything we have ever imagined. Every possibility might play out somewhere in the multiverse. Every choice, every variation of history, every potential universe could exist simultaneously. This raises strange philosophical questions. If infinite versions of ourselves exist across different universes, what does that mean for identity and destiny? Are our choices unique, or are they simply one path among countless others unfolding in a parallel realities? Some scientists argue that the multiverse might even help answer one of the deepest questions in physics: why the universe exists at all. Instead of a single cosmic beginning, there might be an eternal process constantly creating new universes. Our universe would simply be one chapter in an endless cosmic story. Yet, there is also a humbling side to this idea. If the multiverse is real, then our universe may not be the center of existence. It could be just one of countless universes scattered across an infinite cosmic landscape. Still, even if other universes exist, the chances of traveling to them may be practically impossible. The distances between bubble universes could be far greater than the size of our observable universe, and the energy required to cross such boundaries might be beyond anything the laws of physics allow. Some theoretical ideas suggest exotic possibilities such as wormholes or higher dimensional shortcuts that could connect different universes. But for now, these remain speculative and far beyond our technological capabilities. Yet the human drive to explore has always pushed beyond what once seemed impossible. Not long ago, the idea of detecting gravitational waves or photographing a black hole seemed like science fiction. Today, both have become reality. Perhaps one day our descendants will develop tools capable of probing deeper into the structure of reality itself. They might discover evidence that confirms or disproves the multiverse. Until then, the concept of parallel universes remains one of the most intriguing possibilities in modern science. It sits at the boundary between physics and philosophy, between observation and imagination. The truth about parallel universes may still be hidden beyond the edge of our cosmic horizon, but the journey to understand them is already reshaping how we think about existence, reality, and our place in the cosmos. Because if the multiverse is real, then the universe we know is not the whole story. It is only one version of reality among many. And somewhere in another universe beyond our reach, another civilization might be looking up at its own sky, wondering exactly the same thing. Are we alone in existence, or just one universe in an infinite sea of worlds?